Hello everybody, this is Tommy and welcome to my week 2 explainer video for Physics 40B. Today we'll be going over problem number 53, and essentially what this problem is asking is we have a plastic hemisphere and we have it inside some water. We're trying to find the maximum mass that we can put inside of this plastic hemisphere without having it sink. So essentially what this is asking is we want to find the maximum weight that we can have inside of this sphere without being more than the buoyancy, because if the force of the weight was more than the force of the buoyancy, of course it would sink. So we're trying to find how much weight we can put in so that the force of the weight equals the maximum buoyancy force that we can get. And that's just the maximum volume of water we can displace with our object, which is also the volume of the hemisphere, which is in this equation right here. So essentially we're given the mass of the hemisphere, which is 0.21 kilograms. I've converted it to kilograms to make it more easier to calculate, and the radius, which is 0.04 meters from 0.8 centimeters, and that's the diameter, and half of that, and this is the radius. So we start out with calculating the buoyancy force. The P is the fluid density. The fluid we will be putting our plastic hemisphere in is water, so that's 1,000 kilograms over meters cubed, if I'm not mistaken. And we need to find the volume, which is given by the volume of a hemisphere equation, which is 2, so it's multiplied by 2 pi, the radius is 0.04 meters cubed, and that's multiplied by g. Now, some of you might be looking and you may have realized that around here I have made a mistake. If you're wondering, yes, this is a recording of a recording, and I am making this because 1, I don't know how to edit videos, and 2, I forgot to divide by 3, but the numbers are still correct. I've pretty much pre-calculated everything. I just forgot to put the 3 in the video. So, for those of you that thought it was an actual recording instead of a recording of a recording, well, get pranked, I guess. Well, enjoy the rest of the video, if you can. E, which is the gravitational constant, which is 9.81 meters per second squared. So then when we multiply all of these together, we get something around 1.314 newtons. My 4 looks a little bit weird there, but yes, this is a 4. And since this is the force of the buoyancy, we set it equal to the weight force, which is mg. So mg equals 1.314 newtons. Divide both sides by g, which is just 9.81. So we get m is equal to 0.134 kilograms. And one of the most important steps, some students might try to stop right here, but we have to remember that the bowl has some mass too, and it's 0.021 kilograms, so we have to subtract this to find the mass of the rock that we want to put in. So that's minus 0.021 kilograms, and that's equal to 0.113 kilograms for our final solution. Thank you.